By definition, an atom is said to be the smallest particle of an element that can take part in a chemical reaction. An atom has three fundamental particles. We have the proton, the neutron, as well as the electron. So these are the three fundamental particles of an atom: proton, neutron, and electron. Alright, the proton and the neutron, they are found in the nucleus of an atom. The proton and the neutron, they are found in the nucleus of an atom. So we can say that an atom is basically categorized into two: the nucleus and the electron. Inside the nucleus, that is where we have the proton and the neutron. So with this, we can come to the conclusion that an atom has three fundamental particles: the proton, neutron, and electron. Just know that proton and neutron, they are found in the nucleus of an atom. The next thing we also need to take note of is that proton and electron, they are electrically charged. So what I mean by that is that proton has a charge, electron has a charge, but neutron has no charge. Proton is said to be positively charged, electron is said to be negatively charged, and neutron, like I said, it has no charge. So proton, it is positively charged, electron, it is negatively charged, whereas neutron has no charge. So here is a typical structure of an atom. So like I said earlier, I said an atom has nucleus and has what? Electron. Inside the nucleus, that is where we have the proton and the neutron. So from this diagram, here is the nucleus. The nucleus is housing the proton and the neutron. The P here represents proton and the N represents the neutron. And then we have the electron. So the electron, they are found in the shell. The electron, they are found in the shell. So this is what we call the shell. From the diagram down, an atom has a nucleus being surrounded by the electrons, but the electrons, they are found in the shell. And we need to take note of this, that in an atom, we have 7 electron shells: the K, the L, M, N, O, P, and Q. We can call it 1, 2, 3, 4, 5, 6, 7. So we have 7 electron shells. So from this diagram now, we only have 2: the K shell as well as the L shell. Please take note of this. So I said an atom consists of proton, neutron, and electron. The proton and the neutron, they are found in the nucleus. And then we have the electron. The electron, what they do, they move around the shell. They are known to be mobile. And why do they move? They move because they have light mass. The mass of an electron is said to be 1/1840. 1/1840. That is the mass of electron. It is very small. So this is the reason why we have electron moving around the shell. And I said from the diagram, we have the nucleus. The nucleus housing the proton and the neutron. And we have the electrons moving around the shell. So next thing now is I would be explaining to us how we can find the number of proton, the number of neutron, as well as the number of electron of an atom. So let's say the X represents the atom. This A here actually represents the mass number, and then Z here represents the atomic number. Again, the X here represents an atom. The A there represents the mass number of the atom, and letter Z there represents the atomic number of the atom. Please take note of this, that the mass number of an atom, is also known as the nucleon number. The mass number of an atom, it is also known to be the nucleon number. Nucleon number. I didn't say nucleus now, I said nucleon number. And what make up a mass number? The sum of proton and neutron will give us mass number. It is the sum of proton and neutron. The sum of proton and neutron will give us mass number. And I said Z here now, it is the atomic number. And another name for atomic number, it is the number of proton. Please, this is very important. X here represents the atom. A represents the mass number. Z represents the atomic number. And I said the A here also means the nucleon number. And how do we get mass number? It is by adding the proton and the neutron. How do we get the Z now? It is the atomic number, which represents the number of proton. By now we know what we call atomic number. So once you know the first 20, the first 30 elements in the periodic table. So let's take for example now that of sodium. Sodium in the periodic table falls under position 11. So that means that the atomic number of sodium is 11. So let's pick aluminium. Aluminium in the periodic table, it falls under position 13. So that means that the atomic number of aluminium is 13. Also indicating that the proton number is also 13. All right. So now, when I have neutron, if I want to get neutron, so neutron is going to be gotten by we having A minus Z. That is, the mass number minus the atomic number will give us the number of neutron. The mass number minus the atomic number will give us the number of neutron. But the sum of proton and neutron will give us the mass number. So let's take some examples. So here is an example. This is sodium. Sodium has its atomic number to be 11 and then the mass number to be 23. So the question is, what is the number of proton? What is the number of neutron? What is the number of electron of this sodium atom? Before we continue, please take note of this, that for any uncharged atom, for any atom that has no charge, for any uncharged atom, the number of proton is always equal to the number of electron. For any uncharged atom, for any atom that has no charge. If you have an atom that has no charge, just like this now, it has no charge, no plus, no minus. So for any atom that has no charge, the number of proton, which is the atomic number, representing the position of elements in the periodic table, is always equal to the number of electron. So let's get to answer this. What will be the proton here? The proton, for what we have here, represents the atomic number, which is Z. So here now the proton here is 11. And because I said for any uncharged atom, the number of proton is always equal to the number of electron. That means electron 2 here will be 11. So how then do we get the neutron? The neutron will be 23 minus 11. For what we have in our neutron, that is A minus Z, the mass number minus the atomic number. And 23 minus 11, that gives us 12. So the answer here is 12. Very easy. So once you know this, you'll be able to calculate proton, neutron, and electron. So let's take another example. Let's say we have chlorine, 17 here, 35 here. Then the question says, calculate the number of proton, the number of neutron, as well as the number of electron. So for this now, what will be the number of proton here? It is 17. That is the atomic number. And this atom here has no charge. So for any atom that has no charge, just know that the number of proton is equal to the number of electron. So here too will be 17. And for you to get the neutron, that is the mass number minus the atomic number. And that gives us 18. And remember we said to get mass number is the sum of proton and neutron. So when you have proton and neutron added together, you are going to get the mass number. So for me now, 17 plus 18 will give us 35. Same thing with this now, 11 plus 12 will give us 23. I believe you understand. So here's a question for you. Give me your answer in the comments section. So for magnesium, which is 12, 24, and then for aluminium, 13, 27. So calculate the number of proton, neutron, and electron for each of these atoms. Please give me your answer in the comment section. Thank you very much. See you in the next class.